Okay, very good morning to all the participants who have joined us for second week of Python programming for data science and machine learning program. We will be organizing this training on 14 January till 18 January from 7:30 a.m. EST. We will be using Google Collaboratory to write our codes on Python, and we will be implementing machine learning frameworks on real-time data sets in order to acquire knowledge. So that's what is going to be the objective of this week. We will be working majorly on supervised learning this week. Under supervised learning, we will take up data sets for student marks prediction, we'll take up data sets for house price prediction, and we will also look some big data sets available on public data sets from Amazon, from AWS, and various others. So you are going to have a look into that. Apart from that, you will explore Google Collaboratory. Using Google Collaboratory, you will be implementing machine learning models on data sets to acquire knowledge, as well as we will also be discussing Data Science Studio tool from Data IKU 5.0, which is one of the best industrial tool available as of today for performing data science and comparing various algorithms available for machine learning implementations. So let's go for it. I'm quickly sharing my screen with you all. So to get started with today's session, let me just take you to the notepad file, just what we will be covering today. So our objectives of the day. Okay, so the objectives will be, first thing, we're going to create a linear regression model for prediction of student marks. This is going to be the first step which we are going to perform. We're going to create linear regression model for prediction of student marks. Once we are done with the model, we're going to fit the model for calculation of slope and intercept. Slope and intercept. Then what we are going to do, we are going to calculate accuracy of model using metrics like calculation of R2 score value. This we also call it as R squared. Apart from that, we are also going to calculate certain other metrics, and these are known as mean absolute error, root mean squared error. We are going to calculate this. So using this, we will be able to identify the accuracy of the model and if it's the right fit or not. So our objective in general terms will be, we have to acquire a mathematical equation which can predict response variable, that's called as y, the variable represented on y-axis, using independent variables, and let's say this will be x, the variables represented on x-axis, with highest accuracy and minimum error rate. With highest accuracy and minimum error rate. So that's what we are going to identify. Then you will be generating plot graphs for comparison of actual values of marks versus predicted values of marks by our mathematical model. So mathematical model is equivalent to mathematical equation. Okay. So this is what you guys are going to do today. Now, so to get started, we are going to make use of certain information. So the data set which we will be using will be student hours and marks. This will be student hours and marks data set. It is located on Google Drive. So I'm going to share the links with you all. The integrated development environment which we will use will be Jupyter Notebook, will be provided to us through collab.research.google.com. So this is what we are going to do. So now let me just quickly take you to the data set which we are going to refer in today's talk. So I'll take you to the data set. As you all remember, we have created our data set on Drive, and I have already told you how you can directly read the data from the Drive itself. And you can quickly read it in a pandas data frame on your Jupyter Notebook. And please confirm me if I'm audible to all the participants and if my voice is proper. Since I'm connected to another network, I would be taking 1 minute to connect back to the potential network, which can avoid hassles of disconnectivity. So give me a moment. I'm just reconnecting back with the internet. Yeah, so in the chat, please confirm me if my voice is audible to all the participants. Okay, great. So as you can see, we have a student data set available, and I'm going to show you the data set which we are taking. This is just a dummy data set to get you all started with the machine learning framework so that you understand the machine learning framework step by step. This data set is just used in motivation to make you understand the machine learning framework and implementation. And once you are comfortable with the implementation, then we will take up some big data sets wherein you can actually explore various possibilities of machine learning and how it has to be done. Now, so the data set is available with us. I have published it to the web so that it is accessible publicly. So I'm exporting the entire sheet as a comma separated value, which is available on this link. And I'm sharing the link with all the participants on the chat box so that you all will be able to explore the data set along with me. So I have sent you a link to the database, to the data set, which we will be using during this session. This is the last data set which we have considered in our last discussion, wherein we plotted some scatter plots. So I will give you a quick revision to what all we have done, and we'll proceed from there. So I hope everybody has got this information. Everybody has got this data set wherein we have a few observations on number of hours a student has studied and the marks he scored. So using this information, we have to make a machine learn about what is happening in the data. And then the machine should be able to predict if we provide a new observation or a new record of hours to the machine. So machine should be able to predict the mark score of a new student coming in. So that's what is going to be the objective. So just to give you a quick brief of the technical objective, which we will accomplish using this data set. So let me just call it as a technical objective, which you guys will be doing here under this. So what we're going to do, using the data set, we will make a machine learn about what happened in the data and why did it happen, so that machine should be able to predict marks of a student if hours studied of a new student is provided to it. Okay, I hope the statement is clear. So using the data set, what we are going to do, we will make a machine learn about what happened in the data set and why did it happen, so that machine should be able to predict marks of a student. Okay, so the result of what happened and why did it happen will be represented using an existing mathematical equation. I have also shared one document with you, which was Python machine learning document, in which I have shown you a sheet wherein different categories of machine learning were listed. So let me just quickly give you a reminder to that as well. So if we talk about machine learning is divided into three categories: supervised, unsupervised, and the third one is reinforcement learning. So these are the three ways. So when we talk about supervised, so supervised is a case when the data set is structured. Or else you can also call it as if it is labeled, if you can understand the data. For example, an SQL table, okay, a structured query language table. So we do supervised learning whenever data is structured, and as you all can see, the data set available with us is structured, and we can easily represent the information of these numbers from 2 to 10 as hours studied, and we can represent these numbers from 34 to 95 as marks scored. So this we consider as a structured information wherein the values are labeled with column names. So if the data is structured, then what you can do is you have to identify a response, a response or a dependent variable. We call this variable as dependent because your learning will be dependent on this variable, which actually means this machine learning will be done under the supervision of this dependent variable. Okay, so the supervision will be dependent on the variable which you want to predict. So for example, if I take here, so I am going to say marks scored variable is going to be the dependent variable. Then what you do, you have to identify, let's say this is, now there are two ways of performing supervised learning. So supervised is again divided into two categories. So supervised categories, the first category is regression, and second category is classification. So if your response variable is quantity, if it is a quantity, okay, so then you have to perform regression. And if response var is category, then we perform classification. So as of now, if we quickly see the data set available over here, and let me just annotate. So the first thing I check is the data which I am processing, let's say the student data set which I am processing, is it labeled or not? So I see yes, it is labeled. So that means it is structured. Now when I got to know it is structured, so it is clear I'm going to perform supervised learning. So in order to perform supervised learning, my first objective could be that I would like to predict the marks scored of a student. let's say if I want to predict this. So this is going to be my dependent variable. I'm going to call this as my dependent variable, or you can also call it as a response variable. Okay. Our machine learning will be done under the supervision of this dependent variable. Okay. So supervision will be dependent on this mark scored variable. Now, so once you have got the dependent variable, now you have to check the type of the values which this variable represents. So if I see here, the type of the values which are represented here are quantity, because mark is represented as a quantity. So since the type of variables is a quantity, we use regression for prediction. Okay, so that's what we got to know using the information available to us in the data set. And all the other variables which will be left. So these variables which will be left, these will be known as independent variables. We're going to call them as independent. Okay. So one more information which you have to understand. So independent variables are those variables which will be represented on x-axis, and dependent variables are those variables which will be represented on y-axis. Is that clear? If the information till now is clear, please confirm so that I can continue further. So with the data set, you got to know that we have two variables. I will be using mark scored for prediction. I will consider mark scored as the dependent variable on which my machine learning will be supervised. Now, when I check the type of the variable, I get to know it is a quantity. So I will be using regression for prediction. If it would have been a category, I would have gone for a classification. Okay. Now, so once we get to know that we have to perform a regression, so we are going to make use of regression equation in order to implement our mathematical equation and in order to identify certain important things. Okay. Now, what we are going to do? So when we get to know that we have to perform regression, let's say if I get to know from here that I will be performing regression on the data set, the next question comes to your mind is, what is regression? Okay. So regression, either we can quickly refer to the Wikipedia page. We also had a discussion on this in the previous session, wherein we draw a graph and we have represented regression with y is equal to mx plus c. So those people who are new to this session can also refer back to the previous video to get the utmost detail of what a regression is, because we had a discussion on it. I'm also going to give you a quick recap of it today also, as soon as we plot the graph. So when I talk about the regression, okay, so regression can be mathematically represented with this equation. Y is equal to m into x plus c. So using this equation, you can represent regression. Now, what is the meaning of this? So if I tell you that y is going to be the value which is going to be represented on y-axis, let's say it is going to be the mark scored. X is going to be the value which will be represented through x-axis. So we got y and x. Now the values which you see here, the values for y-axis and x-axis are known as actual values. Okay. So let me just type in an important information here. So what we do is, now when I say that I have to perform regression for prediction, this actually means I'm going to use regression equation for prediction of y-axis values when new x-axis values will be provided. Okay, let's say this is what we are going to do. That is the major objective which we want to perform. We have to perform regression equation, and initially I believe that regression equation may be one of the equation which can help me predict the y values when new values of x will be provided. Now, in order to do this, in order to perform this prediction, what does that mean? The meaning is that if the value of new x is provided to you, and if you know the value of m and c, you can easily predict this y. Okay, so that means you can predict the future. You can predict the future response variable. But in order to do this, we need first to calculate the values of m, and we need to calculate the values of c. And this calculation is known as model fitting. Okay, so what exactly we are going to do? Let me just quickly type the statement here. So using actual values of y and x, we have to compute values for m and c using slope equations. Okay, what is that equation? I'm going to show you. So we are going to do this using actual values of y and x. We have to compute values of m and c using slope equations. This process is known as fitting the model. Okay, this process is known as fitting the model. So let me just quickly type in here so that that's clear to all of you. We call this process as model fitting. Model fitting. Okay, this is known as model fitting. So calculation of m and c on the basis of y and x, actual values of y and x. So first is going to be, there will be two processes. Okay, when you perform machine learning, there are two processes. The first process is fit the model. Fit the model means fit the mathematical equation. And second step is predict using model. We have to perform these two steps. Okay, so to perform these two steps, we will have a fit function and we will have a predict function, which you're going to use today. And you're going to understand how we do that. Is that clear? So objectives of machine learning is to perform these two things, fit the model and predict using the model. So how am I going to do that? I'll let you know. Till now, if there is any query, please ask me. If you have any queries with respect to variables, with respect to equation, with respect to objectives, I can quickly answer. If there is a question, let me know. If there is no question, let me know about it as well. Is it clear to all the people till now? Just confirm me on chat. Okay, great. So I think it's clear to everyone, to all the participants. Wendy, is it clear? Okay, great. Now, so let's go to the next step. So now we are going to perform this on practically using Python programming language. Okay. So one thing to let you all know, this regression equation comes from a library known as sklearn.linear models. We have a library known as sklearn. Within sklearn, we have a class known as linear models, which contains this equation, regression equation. So when we talk about Python, if you want to implement linear regression in Python, you have to use this library. Okay, is that clear? So we are going to import this library, sklearn.linear models, and then we are going to implement this equation. Now, before proceeding further, I would like to give you a very important information. One important information which I would like to give you before proceeding further. This information is calculation of how we calculate the slope. So let me just clear all the drawings as of now. If you all want, you can quickly take a snap or a snip of my screen so that you can refer it whenever it is convenient. So whenever you need to take a snip of my screen, you can always go to your start window and you can use snipping tool. So when you use snipping tool, you get a screen like this. You can select the screen, copy the image, and it is going to be converted into an image and you can quickly save it. So you have that option. Okay. So you get an option like this. You can quickly save that image with your convenience so that you can use it later for any other purposes. Okay. So you can also make use of the snip. Now, the important information which I would like to give you is so I need to display you the slope equation. Okay. So what we can do is, in order to calculate M and C, we make use of slope equation. So we need to calculate M, which is the correlation coefficient, and we need to calculate C, which is intercept. So I'll just type it here. Fitting the model stands for computation of parameters in equation. Okay. When I consider regression, then it signifies, if I talk about regression, this is the regression equation. So when I consider regression, calculation of M and C is known as training or fitting the model. Okay, training the model or fitting the model. We call it like training or fitting. So now the equations to calculate M, which is correlation coefficient, and C is intercept, are as follows. So now I'm going to show you the equations which will be responsible to calculate this M and C. Now, to calculate this, you can quickly go to this line, find the equation of a line that you know, a point or the line, and somewhat like this. Let me just quickly see if they are sharing the equation with us here. Otherwise, I'll quickly take you to some better resource which I generally use. Okay, so I'll just take you to, okay, so this image actually gives me the right equation using which I can quickly calculate the M and the intercept. So if I just click here, okay, so if you want to calculate M, what you can do is you can take value of y-axis. Let's say if you have if I have to calculate M, so this is change in y divided by change in x. So what we say, we call this as change in y. So let's say if the y was at y1 position and then the y switched to y2 position. So whatever change is accounted here, the ratio of that change with respect to change of value in x is going to give you M. That is dy by dx, which we have already discussed in the previous image or the previous session. We have already discussed that, how we calculate M. I would like to give you the best mathematical equation which is generally used in order to perform and calculate this, so that you will be pretty clear. And intercept you already know. The intercept is the value of y when x is equal to 0. Okay. So if I talk about intercept, the value for c, so this is going to be something like this. So if I consider this graph, when the x-axis is 0, the value of y is known as the intercept. Okay. Now, so if I just depict these statements here, let me just quickly go to clear the drawings and I'll write that over here. So here, so m is slope, and we also call it as change in y with respect to change in x. This is how we calculate m, and c is the intercept value of y when x is equal to 0. I hope this is clear. So now you can quickly calculate m and c on the basis of y values and x values. So this is known as training or fitting the model. So when you have the actual values of y and x, you perform y2 minus y1 upon x2 minus x1 and you get the x. You get the m, and you also get the value of c. But there are certain improved scientific equations which can also be used. Improved scientific equations for calculation of m and c. So what are they? Let me just quickly tell you. Because generally, this statement which we have given you is a general statement. Okay. But when you have to implement that in industry, you're going to get a lot of values for y and x, and there will be a lot of deviation. So it will be very difficult for us to calculate m for each variable. So in order to do that, we have a very simple equation using which we can calculate the values of m. So my objective is to share that equation with you so that your mind gets to know the behind the scenes part when we will be discussing those equations, when we will be fitting that information. So let me just quickly take you to that equation. So slope equation, I would like to refer slope equation in statistics. So I've searched for slope equation in statistics, and I'm looking for a resource which I generally prefer. I have one here, statistics how to. So you need to give me a moment because actually I've got the right resource. So I'm just sharing the right resource with you all on the chat box so that you guys will also be able to open this resource. Now, here on this resource, you can quickly understand the regression and the equations which are used. So I would like to take you to the bottom of this regression analysis, and I would like to show you the equations. So this is the equation. So if you can read the statement here on my screen, linear regression is a way to model the relationship between two variables. So we have two variables. One is hours studied and second is student marks. You might also recognize the equation as the slope formula. The equation has the form y is equal to a plus bx, where y is the dependent variable. So in our case, the dependent variable is marks scored. That's the variable that goes on the y-axis. And the second information is x is the independent variable. That is, it is plotted on the x-axis. B is the slope of the line. So the B value which you are seeing here is equivalent to m in our case. When we consider the equation y is equal to mx plus c. So the B which is displayed to you here is equivalent to m in our equation. So if I annotate that here, let me just quickly annotate that here for you. So here they say y is equal to a plus bx. Okay. And what we have taken was y is equal to c plus m into x. Okay. So it's one and the same thing. So C will be considered as A and B will be considered as M. This is just to represent you the variables which they are using and what we will use. Now, so when you see, we have this information available over here. Now, this is the equation for calculation of intercept. So if you want to calculate the intercept programmatically in Python, then this is the way. You can calculate the intercept using this formula, wherein you can take the sum of all the values of y, then you can take the sum of all values of x, square it, then you can subtract it with sum of all the values of x and product of xy. So this is how you can calculate intercept. And this is the equation using which you can calculate the slope. Okay, so this is how you can calculate M. So we call M can be calculated like this, and your intercept can be calculated like this. So now what we have to do is, certainly it looks a little complex, but if you use Python and if you use libraries, then you can quickly do this task in a minute just by executing a line of code. So how we are going to do that, I'm going to make you understand it. Okay, so what exactly we're going to do? Yeah, how will you make your editing tool active in Google? I just didn't get that. What is that question? Acha, you may be asking, how am I annotating it? Yeah. Actually, so the tool which I use is Zoom video conferencing tool, which allows me to annotate on the browser and on anywhere on the screen. So I annotate using that. Now, so let me just quickly take you back to what exactly we're going to do. So now, if I just give you some line of statements relevant to these equations, which we will be implementing in, so that you have the clear-cut idea. So what we are going to do when we talk about Python, we're going to import sklearn. Okay, you're going to import sklearn linear model. Now you're going to create an object of linear model as LM. What exactly you're going to do? So let me just call LM model represented as LM, linear model represented as LM. So using this object, we are going to create linear regression object. Okay. So when I call linear regression object, I'm going to store that into LR. And now LR will be represented with this equation. So when I write this in Python, so the LR will represent this equation or else this equation. Okay. Now what am I going to do? In the next step, what I'm going to do, I'm going to pass LR.fit. When I'm going to pass LR.fit, I'm going to give the values of X and Y. So this actually means supplying actual values of X and Y to calculate M and C. Okay. So this statement will mean give actual values of X and Y to calculate M and C. So when we do that, when I'm going to use this equation LR.fit, then what is going to happen? When I'm going to call this LR.fit, or else let me just take red color so that you can quickly observe it. So when I'm going to perform this LR.fit, so both of these equations will get executed behind the scene, and I'm going to get the values of M and C, or else you can also call it as A and B. I'm going to get these values. So when I'm going to get these values, what I'm going to get in return, this LR.fit is going to give me these two variables. So one will be LR.coefficient. Okay. One will be LR.coefficient, which is going to represent the value of M, or else you can also call it as A. And I'm going to get another value, LR.intercept. So this value is going to be either sorry, this is M or B, and this could be the C or A. So I'm going to get these values. Now, when I get these values, post that, what I'm going to do, I'm going to execute the following statement. The next statement which I'm going to perform will be lr.predict. So using the values of x dash, you can consider it as when I pass the new value of x using lr.predict function, I'm going to get the new value of y dash. Okay. And behind the scenes, what is going to happen? So when I'm going to pass the values of, so when we will be performing lr.predict, what is going to happen? We're going to use the calculated value of m. We're going to use the calculated value, the given value of x dash. We're going to calculate the value of c, and you're going to be able to get y dash in return. Okay, so that's where the output of prediction is y dash. This is what you're going to get in return. So if we see here, so C is going to be the intercept and M is going to be the coefficient. So that's what we're going to perform. I hope this is clear. And I've got a chat message. Let me just quickly check. So I get collab.research.google. Okay. So I think that is helping some questions and answers. Fine. That's fine. Now, so I hope this is clear till now. If anybody has any queries till now in explanation of the sessions, please let me know so that I can help you out. And for reference of these images, I will try to quickly put that onto a file wherein you can access these. So I think I have saved all these charts here, screenshots. Maybe they may be saved or not. I just need to check. So what you can do is, if you want, you can take a quick snip of the tools so that you can refer it. So let me just make a snip of it, the linear regression, and we can save it. Okay, now, so I just clear it now so that we can proceed further with the implementations. So till now, is it clear to all the participants? Let's just reach to the next part and get started with the code. So shall I proceed? Just confirm me on chat. Yeah, I'm going to give you a quick recap. I've got a query from Hussein. Can we have a quick recap? Yes, definitely. I'm going to give you a quick recap. As soon as I write the code on Python, I'm going to give you a quick explanation to it. So now what exactly we're going to do? We're going to implement linear regression. Let me just put it on one side so that you will be updated with what exactly we will be implementing in. Okay, yeah, so that's what we are going to implement during this. Let me just put it here on the left-hand side. And let me just start collab.research.google.com, wherein I will be coding the stuff. Okay, so a little adjustments will help you understand the concepts well and better. So now, so we go to collab.research.google.com now. Okay, we're getting started with the code now for the day. So let's just quickly get started with a new Python notebook so that you can implement all these process step by step. Okay, now, so what we are going to do, I hope everybody is able to see my screen properly. I'm getting a few chat messages here. Yes, okay. Now, so we are going to implement machine learning using regression. So this is going to be the first example. So let's implement stage one. The stage one is data collection and selection. Okay. So framework which we are using is knowledge discovery process. We're going to call it as knowledge discovery process, KDD. Let's go with the stage one, data collection and selection. So what we're going to do, we're going to read the data from a source. So as I have already told you, we're going to import the library, import pandas as PD. Let's create the object of PD. So we are going to use it. Now we are going to use pd.read comma separated values, and we are going to read the data from the source. So the data from the source is already sent to you all on chat. You all have the source for the data which we will be using. This is also available on Google Drive, and I have also given you a public link to that. So I just copy that URL and I quickly paste that here. So this URL will be from docs.google.com from the spreadsheets which I will be using. So just to show you, it is going to be a CSV file which I'm going to use, and this is the web public link to access my data set. Now when I get this data set, I'm going to store that into data frame, and I would like to quickly show you the information of what I have got. So when I run this, when I read it, my data set will be read. So student mark data will now be stored into this data frame. Data frame is a two-dimensional size mutable data structure which can represent, and I have displayed top 5 values from my data frame. So these are top 5 values, and this shows me I have successfully got access to the data for further analysis. So if you all are done till now, please confirm so that we can go to the next stage. Please confirm me on chat if you guys have done it till now. Okay. Now, okay. So we have got the data. Now let's go with stage number 2. So stage 2 is pre-processing, okay, which I'm going to explain you with a big data because at the moment we already have numbers. So what pre-processing does, remove/replace missing values. And in our data, we actually don't have any missing value as of now because the data set which I have taken is a dummy data set. So I can ignore this step as of now. Then the second step of pre-processing is to convert text into numbers, into numeric. Okay. So what we have 2 variables in the data set as of now, and both are numeric. So we don't need to pre-process this at the moment. Then the next stage which we have is this stage is transformation. Okay. So transformation means scaling all variables of different range to be represented on a same scale. And this is going to be, for example, between 0 to 1. So sometimes for comparison of all the variables in the data set, we have to rescale or transform the variables of different range into the same scale. What is the meaning of this statement? Let me just quickly tell you. So if you see the data set here, you can see if I annotate it here, so the meaning of transformation is if you see marks code, the range of marks code is from 34 to 95. Okay, this is the range of marks code. And if you see the range of hours studied, it is 2 to 10. So if we represent both of these values on a graph, I'm going to get a graph somewhat like this. Let me just quickly draw a graph for you. So let's say if I make a graph, so one value will be represented somewhere here and second value will be represented somewhere here. So let's say this is going to be the hour studied value, and this is going to be the marks value. So now it's very difficult to compare both of them. Okay. And it could also be possible in certain data sets, there could be very high values. Let's say if we talk about housing price data set, so price can be represented into crores. And if I compare it with bedrooms, so bedrooms will be like 1, 2. So it will be very difficult for us to compare both of them on the same graph. So in order to do this, what we do is we send them to the transformation stage. Okay. So what we do is we rescale or we perform transformation. So the output of transformation is when you do the transformation, so both the values, your value of 2 to 10 will also be represented between a range of 0 to 1. And you're going to complete this process in the upcoming classes. I'm going to tell you how we actually do. And values of 34 to 95 will also be represented between the scale of 0 to 1 after transformation. So this is the meaning of transformation. So if you perform transformation, so your values will be represented between 0 to 1, and values of other scale will also be represented into the scale of 0 to 1. So this is what we call it as rescaling and transformation. So if this is clear to all the people, there are certain techniques to perform transformation, and these are known as standardization and normalization. Okay. So we do that to convert that scale, and I'm going to address these information as well. So rescaling and transformation is done using the following process. So what we do, the first is known as standardization, which you're going to understand. So standardization is something wherein you subtract the mean and divide with the standard deviation. And second one is normalization, in which we generally use feature scaling, and it is also known as min-max scaling. So I'm going to make you all understand these steps when we will be working on housing data set, because housing data set will be there. We have like these scenarios wherein we need to rescale and transform the data. Okay, because you will have data of various range, but as of this data set is concerned, you can quickly see that they are like of nominal range, so we can ignore these steps as of now. So let me just clear all the drawings and let me quickly take you to the code. So now if I talk about the code, so here we can ignore these two processes. We can ignore pre-processing and transformation. Now once pre-processing and transformation has been done, now comes the stage of the important stage, and this is data mining. Okay. So we are going to perform data mining using regression. To use regression, we import sklearn.linear models. So we import linear model and we create an object for it known as LM. So I want all the participants to execute this. So I'm doing this import for linear model so that I can get this equation. Okay, the equation of the form y is equal to a plus bx. This I need to get. So this equation y is equal to a plus bx in Python can be quickly accessed using linear model. So how am I going to do that? Let me just show you. So what I'm going to do, now I'm going to use linear regression. Okay. To use linear regression, I'm going to access lm.linear regression. So this is the constructor in order to create an object of linear regression equation. So when I run it, now your linear regression is here. So LR is going to represent this equation. Your equation y is equal to a plus bx is going to represent it with this. Is that clear to all the participants? You can quickly push me a chat message if you're clear till now. Okay, so as you already know, linear regression is a way to model the relationship between two variables. So if we say two variables, what these two variables could be? These two variables could be our studied and marks. Okay, so if I quickly show me the two variables. If I show you the two variables, I have df.columns. If I run this statement quickly, okay, and it would be better if I use the print statement. Show me variables. Okay, so I'm going to show you the variables, and these variables will be our studied and marks. Okay. So you have these variables, and it would be like better if I just quickly put print df.columns because I'll be able to represent it now. So if I annotate that now here, so I have two variables. One variable is y and second variable is x. So if I take y variable, so y variable, this is going to be represented with marks scored. Okay, and I have a variable x here. So x is going to be represented using hours studied because I'm going to represent x on x-axis and y on y-axis. Okay, is that clear till now? I hope this is clear. Now, so let me just take you to the next step. Okay, now let me just take you to the next step. So when you have got linear regression and you have these two variables, now what exactly you're going to do? You're going to select the variables. So get the variables to represent on y-axis. So that means we have to get the dependent variable. So I'm going to tell it somewhat like this. Let's say y is equal to, I'm going to represent the values of y here. So you can access your data frame. You can quickly access marks scored, and you can convert that into arrays by using values. So we have got the dependent variable, and you can also call it as dependent. Okay, this is the dependent variable. Our supervision of machine learning will be dependent on this variable. Now let's go to the next step. Get the variable to represent on x-axis. Let's represent the x value. So the values which we are going to represent on x-axis will be from df dot hours studied Okay, df dot hours studied, and let's call it as values. So we got the x values as well. And these x values will be the independent variables which will be responsible in prediction of y. Okay, let's run it. So now you have got the values of x and the values of y. So these are the actual values of x and y. Now using actual values of x and y, what you can do is you can calculate intercept and slope. So using the actual values of y and using the actual values of x, you can calculate using the values of y and using the values of x, you can calculate slope and you can calculate the intercept. Okay. A is your intercept and B is your slope. So you can calculate that. For calculation, what you need to do, let's just write a new line of code. So for calculation, let us just first run it so that the values get stored. And what you're going to do now. So fit the model. Okay. Or you can also call it as train the model. Got a chat message. Okay, so I have got a message. Can you please display stage 2 block again? Okay, I'll do that. And I've got a message from Sumit sir. Please explain dependent and independent variables meaning in layman term at later point. Okay. So dependent variable and independent variable is like very simple. So let's say if you have set of variables available in the data set. So the variable which you want to predict is the dependent variable, and the variable which you want, which you believe can help you predict the dependent variable are known as independent. Okay. So let's say if we got to know that our studied can successfully predict marks, so we took marks as the dependent and our studied as the independent variable. So selection of the dependent variable totally depends on your business requirement, that what exactly you want to predict. Okay. So that in general layman terms, dependent variable is something, the variable which you want to predict out of all the variables available in the data set. And independent variables are those responsible variables which you believe can help you predict the response variable. So these variables are represented like this. And Sanika has asked me to show stage 2 block. So Sanika, here is the stage 2 block. You can quickly grab the information here. So in stage 2, we did pre-processing and transformation, wherein these pre-processing and transformation, I'm going to explain you tomorrow in the other data set, which we will consider. That is the housing data set, which is going to have like 500 observations, and we're going to implement these stage 2 and stage 3 there. We have not implemented these stage 2 and stage 3 in the current data set because we don't need it actually. The data set is a dummy data set. It is already clean. It is already pre-processed and already pre-processed. So we don't need to perform these stages on it. So I ignored it. Okay. Okay, got it. Okay. So now, so let's just go to the next step, wherein you have to fit the model and train the model. Yeah. So if you get this DF, Wendy has sent me a question that DF not defined. So this is because your variable, when you have read the data, pandas.read CSV, it has to be read and stored back into data frame. So this is where we have created DF. So what you can do is you can read, you can check your stage 1 function, wherein you have implemented pd.read CSV, and you have to store the value onto this data frame DF. So you can do this step and you can rerun the cell. Once you run the cell again, the values are going to store into the DF, and then you will be able to access it. Okay, so I've got the chat messages. Let me just quickly check. Okay, it's fixed. Great. Now, so let's go to the next step now. So we need to fit the model and train the model. So fitting and training the model exactly means you need to calculate the values of intercept and you need to calculate the values of slope. So this means calculation of this and calculation of this. Okay, if your equation is y is equal to a plus bx. So how we are going to do that? Let us quickly check. I'll go to the next step now. I'm going to use linear regression and I'm going to call the fit function. And let me just quickly show you the help of the fit function so that it is clear to all of the participants. Okay, so if I talk about LR.fit, so it fit the linear model. What does it need? It is going to take X value should be an array. Okay. And it should be of a shape, n samples and n features. So you see that here. So when we have to provide X values, it has to be a 2-dimension sometimes. It should be a sparse matrix sometimes. So how can we convert an array into a sparse matrix? I will also let you know about it. Okay. Apart from that, Y is going to be the array. This is going to be the target values, the value which you want to predict. So when X and Y will be provided, it is going to return you an instance of linear regression. Okay, when you're going to perform fit, you're going to get an instance of linear regression. So when you get the instance of linear regression, what is the meaning of that? So when you get the instance of the linear regression, it means you are going to receive all the properties of linear regression, and the properties are intercept and coefficient, and that you can quickly check back with the linear regression which we have done at the top. So I'm going to explain you that also, what I'm talking about. So let me just quickly clear the drawings first. Yeah. So now what we will do, let's say we're going to perform LR.fit, and to perform LR.fit, you need to pass in the values X, Y. So when you fit this, you will get the values of A and B calculated. Okay. Now let's just run it and let's see what we get in return. So when I do this, it is asking me that I need to give the variables in uppercase because I have taken the values X and Y as uppercases. So let's just rerun it. Now when we run this, so it gives me an error, and that could be due to the shape of data which I have provided. So I'm going to tell you how we are going to use it. Okay. So you can see that when you have passed this values of X is an array, Y is an array, but it is giving me an error that it expected a 2-dimensional array, but it only got a 1-dimensional array. Okay. So what we have to do is we have to reshape our data using array.reshape, or what you can do is you can also convert it into a 2-dimensional array. So how can we convert that? I'm going to quickly tell you. Okay. So the X values which you have provided should be of 2-dimensional array type. So I'll just quickly put that here on Notepad so that you all will get to know. So a quick explanation of what the error was. So for fit function using linear model, we need to have independent variables as a 2-dimension array and dependent variables as 1-dimension array. So dependent variable can be quickly converted using this. You can access data frame, you can access marks underscore scored, and you can use values. So you are going to get the 1D array, one dimension array. But in case if you want to get a two-dimensional array, then what you have to do, you have to use data frame. You have to get your hours studied. Okay. Then you have to slice out all the values. You all have done slicing. So you have to slice out all the values and you have to add these values as a new axis using the numpy array. So what is this NP? To utilize this NP, you also have to import a function known as import numpy as NP. Okay, so you need these two statements in order to create a two-dimension array. So what it is going to do, df.hours, all the values will be sliced out, and these sliced out values using numpy, which creates two-dimensional arrays, it is going to convert your values into a two-dimensional array using this feature np.newAxis. Okay, so the end result of this statement will be a two-dimensional array for x values. So that you're going to get. So how am I going to convert that? Let me just quickly show you. Okay. So let's get back here. Let's get back to the code. So I need to reshape my data. And in order to reshape my data, I will quickly go to the x-axis. Since the x-axis needs to be two-dimension, so what am I going to do? I'm going to change this statement. You can see that I have commented this statement x equal to df. And instead of this, for your clarity, I will be writing the statement again. I'm going to access hours studied. I'm going to slice out all the values from hours. And I'm going to create new axis using np object. And to use this np object, I'm going to import numpy as np. So this helps us create two-dimensional arrays, library for 2D array. And here is an example 2D array which will be generated. Okay. So you can quickly go back to the section where you got the x and y variables, and using this statement, just create x as a two-dimensional array. Okay. So let's rerun this. Now when you run, you're going to get the x as two-dimensional now. If you want, you can also print x and you can see the content of it so as to identify the visible difference between a one-dimension array and a two-dimension array. Moreover, now, once we're done with that, we are going to fit the mod. So when I fit now, you can see that I do not land up into any error now, and my linear regression model has been generated. Okay. So the output of this statement is now we have the values of slope, which is your A, and intercept. Sorry, this is intercept is A and slope is B. Intercept in equation y is equal to A plus bx is calculated. Okay. So what we did, we have got the fit function, and you have got using lr.fit, you have got these values calculated. Now, if you want to see the values, you can also see the values. So slope B is represented as lr.coefficient. It is represented with this property. This is the property of linear regression. Okay. So this gets calculated when we execute lr.fit. And the intercept, which is A in the equation, can be calculated using intercept, LR dot intercept. This is also a property of linear regression. So both of these values are calculated, and if you want to see the values printed, so I'm going to print the values post calculation. Slope, let's say B, is LR dot coefficient, LR dot coef, and you can print the value of intercept, which is A, LR dot intercept. So now you can run both of these. So when you fit now, you can see that the slope is 6.8 and the intercept is 32. So this actually means even if a student will not study for 1 hour, he is going to score 32 marks. And this is because due to unknown reasons, like he may be genius enough, he may be having certain mechanism like having a cheat sheet or something so as to score the mark, or he knows the things, even he doesn't know, but he got to know it with some other sources and he got 32 marks. So this could be due to unknown variables which may not be available in the data set, as well as the slope information which you see here is the change of y with respect to change in x. Now, once we have got this BA calculated, we can predict for the new values of x. Okay, you can predict for the new values of x. If you all are clear till now, just quickly tell me if you have executed till here. Just for reference, this is the B value which has been calculated, and this is the A value, the intercept value, which is calculated. And actually these come when you perform fit. So both of these equations gets executed when we call LR.fit. And A and B are represented using LR coef and LR intercept. Okay, so LR intercept is the property available in linear regression, and LR coefficient is the B property, the change of y with respect to change in x. Okay, so I hope this is clear till now. Yeah, so Sumit sir says slope 6.8 is number or percent? It is a number. Slope is the number. It is not percent. Here both the values represent numbers. Intercept and slope both are numbers. Okay. So now I'm going to plot it and I'm going to explain it. So this exactly means if there is a 1 hour change in x, there is going to be 6 mark difference in the 6 marks difference in the y. Okay, if it is clear to all the participants till now, let me know. So now what we can do is we can proceed towards the prediction. Yeah, so we got a message for time check as well, but don't worry. Let's just complete that so that you all will be clear with it. It's going to be one more step is left. 2 more steps, in fact. One is the calculation of prediction and other is the representation of the graph. Now, so let me just take you to the next step. We'll go a little quick now. So when you fitted this, when you have fit the model, now what are we going to do? Now the objective is predict the values of y for new values of x using regression equation, which is y is equal to a plus b into x. Okay. So what we're going to do, we have the value of a, we have the value of b, we have the value of x dash, the new value of coming. Using that, we are going to predict the value of y. So how we are going to do that? So let's store the value of slope here. Store the value of slope. So let's call it as b is equal to LR dot coefficient. So I've stored it here. A is equal to LR dot intercept. Okay, I've got the values of B and A. Let's say I'm going to predict the values for X1. Okay, so let's say we got a new student and I say, let's say he studies for 6 hours, okay, or 7 hours. So this is a new case, a new student who study for 6 hours, let's say for 7 hours. So now the objective is predict the marks. To predict the marks, we are going to use this equation, LR, linear regression. Predict the marks using linear regression. So what we are going to do, we are going to call the predict function. What this predict function is capable of doing, if I quickly show you the help. So what it does, it predicts using the linear model. So for prediction, you just need to pass in the value of x and it is going to give you the y value. Because it already has the value of a, it already has the value of b, you have given the value of x, so finally he is going to compute the value of y. So x could be an array or it could be a sparse matrix. Okay. Now, and finally it is going to return you an array with shape of n samples. So now n samples as in if your x contains 10 variables, so it is going to predict 10 y's for you. Okay, output of all the 10 variables, hence number of samples which are given in the input will be predicted. So as of now, let's say I give x1 for prediction and I calculate y1. Okay, and if I print this somewhat like this, if a student study 7 hours, machine predicts, okay, let's say I'm going to type in a multi-line statement now. So I'm going to pass it like a list. Okay, I need to pass it like this here within this list. Okay, let's just keep it simple so that let's do it like this. So student score for 7-hour study. Okay, so if a student study for 7 hours, how many marks he is going to score? So we are going to get that marks here using y1, using the prediction function. And this prediction statement actually refers y dash is equal to a plus b into x dash, or whatever the value is, x1. Okay, y1. So when we have given the values of x1, we already have the values of a and b. We will be able to calculate y1 out of it. So when I run it, so here you see the prediction. Now the value which it says, the x1 which we have passed, we can quickly convert it into appropriate shape. So what it says expected 2D array got scalar array instead. Okay, so that won't be a problem. You can quickly pass in like a two-dimensional array, expected 2D array got scalar array. Okay. Let's do that. So what we can do is you can quickly pass in a value for this. Let's say we have got an x1. Instead of this, let's just pass 7, the equation directly. Yeah, just a minute. So it asks me to check expected a 2D array got scalar array 7. So we need to convert that onto, you can quickly convert that into a list. Okay. So what we can do is, again, we can take up x1. Let's say we can take up x1 as a list of number. Let's say it is 7. And I can quickly convert that into new axis again. Let's say we have x1. I can slice out all the values and I can convert it into a new axis, and then I can provide the value here. So you can also do that. So you can pass in the list of values and you can quickly get the output. Okay. I hope this is clear to everyone. Okay, and you just need to give me a moment. Yeah, so you will also get the values directly if you predict using 7. That won't be a problem. So I hope you all have got the values for prediction. Just confirm me how many of you have got the values for prediction. I will quickly check back with my notebook here for the list of values, or else you can use any of those values format to convert it into an array or something like that. So that won't be a problem. You can also call it like this, x1.values. You can convert it like that as well. Or else you can pass in it like a list of element like 7, and then you can convert it into a variable like values. So there are like various ways. So I just need to check back with what exactly I'm passing here for prediction. You can quickly do that. So just confirm me as of now, how many of you have got the values of this printed? So please confirm me. The participants, those who have got the values for Y, and by the time I'll just quickly check. Yeah. So we have got we have got B, we have got A, X1. So Wendy has got the values. So guys, please show me the score which you have got. Just quickly show me the score. You all can quickly push the score values which you have got predicted when your students study for 7 hours. Okay, so just quickly give me access, show me the values which you have got when you perform the prediction. So what I can do is, instead of doing this, what I'll do is, I am going to show you predicted values of X instead. Okay. So what I'm doing here is, I'm going to show you the difference between Y and Y1. So the actual values of Y and predicted values of Y. So let me just quickly save that onto a variable known as predicted Y, so that you will be able to understand. Okay, so yeah, so just quickly see that. So now there won't be a problem. If you guys would like to see that here, I'll show you for a list of values which we will be predicting in. Okay, so instead of this statement, let us just compare the model for all the values of X which are already available with us. So what I did here for prediction, what I'm saying is, I have passed in the values of X, and this is the values of X which are like actual values of X. So I'm going to predict for each value of X available in my data set. Okay. So what is exactly going to happen? Let's say if I have this data set for hours studied, I have this marks scored. I'm going to get the predicted marks represented in the data here. So for the same values of X, we are going to calculate the predicted marks, and then we're going to check the difference between actual versus predicted. Okay. So how will we be doing that? Let's have a look. So I have passed in the values of X and I'm going to get the predicted values of Y in return. And instead of that, I'm going to save these values onto the data frame. And I'm going to call it as predicted marks scored, and I'm going to create a new column known as marks predicted on the same data frame. And then I'm going to show you the data frame. Okay. So if we run that now here, you can quickly see that. So when we run that here, so what exactly I did, let me just quickly show you the data. So I have performed a prediction on all the values of X which are available to me. And I have got a new data frame created somewhat like this. I hope you all are able to see that. So this is the actual values of Y on the basis of hours studied, and this is the machine prediction values of Y. Okay, these are the machine prediction values of Y. Can you see that? So now you can see that now what the machine says and what the machine does, and what is the difference between the actual values and the predicted values. So if you see, if a student is studying for 2 hours, actually he got 34 marks, but the machine says he may get 46. So that's like a difference. But if you see second scenario, if a student studied for 3 hours, the machine said, the actual score was 54 and the machine predicted somewhat like nearby. Here, there is a big difference. Here, there is certain difference. Then here, there is like little close. Then for 89, it is very close. For 92, it is also very close. For 95, it's like a little nearby. So now what you can see is there is a difference between the actual values of the marks which a student got and the values which machine predicted. Okay. So it's not just any equation will do. You have to find out the equation which is highly accurate. So as of now, you need to check the accuracy of the regression equation in prediction of the marks. That's what is the objective. Okay. So what we're going to do, let me just quickly write that on a new cell. I'm going to create a graph, plot a graph to map actual versus predicted values. This is what we are going to perform. Okay. So it's going to be very quick. I have the data frame available. On x-axis, I'm going to have hours studied. On y-axis, I'm going to have actual marks versus the predicted marks. These two plots I'm going to plot. To plot it, I'm going to use matplotlib.pyplot as PLT. Using plt.plot function, let's just make scatter plots. So as far as scatter plots is concerned, I'm going to give you the values of df dot hours studied on x-axis. You're going to get the data frame and you're going to get the values of hours, STUDIED. Okay. Okay, guys, I hope you all are able to see me. Yeah, so just you need to give me one moment. I'm just connecting my machine again. I just forgot to put the plug-in of the charger. So I'm just reconnecting back in a moment. And by the time, if you want, you can show me your screen so that I can quickly check in case if there is a problem. I can quickly check back by the time my machine gets resumed. So you can share your screens. Yeah, okay. So I'm quickly joining back. Okay, so guys, let's have a look. So what we have is, we have got this pie plot created. We're going to get access to the columns hours underscore studded, and we're going to make a scatter plot with the actual values of marks. So let's say, let's just get marks scored. You can quickly plot it, and let's say the color is going to be green. I'm going to make a green plot. Let's just go for one plot. So now you can see that this is how your actual marks looks like. Okay, you're going to get a green plot with your actual marks. In the same way, I'm going to plot a line plot this time, or let's say the scatter plot, wherein I'm going to implement hours underscore studded, and I'm going to compare it with predicted marks. Let's say I'm going to call it as marks underscore predicted. So these two values I'm going to plot on the chart here. Plot dot x label will be hours underscore studded, and on y label we are going to have marks scored, marks underscore obtained. Okay, so I'm making these two plots here. So now you can see that there is a difference between what are the actual values and what are the values which are being predicted by the machine. So the red values are the one which is represented by the machine, and green values are the one which is actually represented by the actual scores. Now here I would like to give you like the lines as well. Plt dot plot for the same values of x and y for actual and for predicted, so that it is going to be more easy for you all to quickly observe. I'm going to plot the machine as well as the actual values in a line plot as well. Okay, so when I run it, so I've made a mixed plot somewhat like this. Okay, if you want, you can quickly observe how I actually plotted both them. So I made a scatter plot. On x-axis I represent hours studded, on y-axis I represented marks scored. Then I made a scatter plot for hours studied with respect to machine prediction marks. And I've also made the line plots for marks scored and for the predicted marks. Okay, for green and red color. And when I compare them now, so you can see that there is a linear relationship among the model, wherein at certain times my machine can predict like accurately. At certain times there is going to be certain difference between the prediction. Sometimes it is very accurate. Sometimes it is very nearby. So now with this, I need to actually identify the exact accuracy of the model. Okay. So I need to understand what is the accuracy of regression model in prediction of marks. Okay. This is a question. So we seek if accuracy is above 90%, then we can use it for deployment. Okay. If the accuracy in prediction of the marks is above 90%, then we can use it for deployment. Can you see that? So there are certain actual values of X and there are certain predicted values of marks on the basis of X provided using the machine learning algorithm. So now that was just one equation, regression. It could be possible there are like 10 equations available which can predict the marks for y-axis, okay, on the basis of X provided. So our objective being a data engineer or being a data scientist is to identify the best equation which is highly accurate in prediction of these marks. So once we get to know that equation, we can give that equation to the web developer so that he can integrate that equation with the solution and the web application can predict with highest accuracy on the new occurrences which will be coming into the system. Is it clear? Have you guys understood it? Okay, so let me just quickly save that image and let me know if you can observe this. How many of you have got this graph? Please confirm. If there is a question, please confirm me. So what we have done till now, we have made a linear regression model using hours studied and marks scored. And on the basis of the model generated, we have predicted the values of marks. And on the basis of actual values and predicted values, we have calculated how accurate the model is. We have actually verified. Okay. Now we need to actually achieve the accuracy. So to identify the accuracy, we do have certain functions available, like we can calculate R-squared values, which we are going to understand tomorrow. That how we can calculate the accuracy of the model. Okay. So let's just need to check the code for the plot. Okay, Sanika, let me just quickly show you. So here is the code for the plot. So it's actually very simple. Just I've used the scatter function and the plot function. These are the two functions which I used. And on x-axis, I have given hours studied. On y-axis, I have given marks scored. Then I have made another scatter plot wherein x-axis represented hours studied, which were the same values of x, and the predicted values of y. And I have plotted it with a green color and with a red color, so as to show you the visible differences between both. Okay, so have you got it? Okay, great. So how many of you have got this graph? Just confirm me. So Hussein, have you got that graph? And Suvit sir, have you got that graph? Okay, not a problem, Hussein. In case if there is a query, you can quickly ask me. Otherwise, you can quickly observe this video again so that you will be able to share me their IPYNB. Yes, I can quickly share you my IPYNB file. So save a copy in Drive. Let me just quickly save this copy. Okay, let me just save it with 14 Jan 2019. Supervised machine learning. Okay, let me just quickly give you access to that, drive.google.com. So I'm sharing the link with all the participants for the script which I created here. Okay, so Hussein, if you can quickly, I'm sending the shareable link with all the participants on chat so that you all can quickly verify that. Here it is. So I have sent that on chat so that you guys will be able to quickly watch it, watch the script. Okay, so just have a quick reference to the script and try to make a plot of this. Now, the next objective from here would be to identify the accuracy of the model which is created. So if you can see that this red line actually represents the machine learning model, and the green line actually represents the facts. So now the objective is to identify that how accurately this red line should actually fit the model. Okay, so what we have to achieve is we have to achieve a machine learning model of red color which can be like able to follow this slope. Okay, we call it as fitting the curves. So we have to fit the curves, fitting the red line with respect to the green line so that we can accurately calculate the marks of the students. Okay, so that's what is going to be the objective. But as of now, if you see, the red line represents our machine learning model, which can predict the values of student marks on the basis of hours studied. And what is the accuracy? That is a question as of now. So we are going to identify that tomorrow, that how we calculate the accuracy of the model. And if the accuracy is above 90%, then we can use that model for deployment. Okay. So if there is any question, please ask me. Rest, we can continue from tomorrow. So just to give you all a quick recap, we read the data. When we read the data, we got hours studied and marks scored. Using the data, we have created a linear regression model, which is y is equal to a plus bx. We have used linear regression model on the values of y and x. So we selected the dependent and independent. We fit the model for computation of slope and intercept. We printed the values of slope and intercept. Using the values of x, slope, and intercept, we have predicted the values for marks for the dependent variables. When we have got the marks, we can see there is certain difference between the actual values of the marks and the predicted values of marks. So we visualized it using this plot, that what is the difference between what model predicted and the actual values. And we have to identify what is the accuracy of this model in prediction. So if we get a model with a prediction accuracy of above 90%, then we can say that we have got the best fit model and we can use it for prediction and for deployment. Okay. Any questions left? Please ask me. So Hussein, have you got the script? Are you able to observe it? Okay. And Sanika, are you done with the with the implementations? Can you show me your screen? I can quickly check back in case if you're getting any error in your graph. I can stop my share and you can share your screen so that I can quickly check the error which you are facing. So Sanika, you can share your screen with us. We will help you out. Okay, so now you can quickly go at the bottom. So one thing is marks predicted is the key error. Okay, so that says it cannot identify your marks predicted column. So if you go a little top, and if you can allow me to request remote control to your screen. So you have used marks predicted with a space character here. If you just observe it, here you have used marks space predicted. So you have to pass in the same name which you are trying to access here. Okay, so just change it to marks predicted, predicted. Then you're going to get the marks. And in the same way, you're going to access marks predicted. Okay. So you have py label marks scored. That is fine. And you have used marks scored and hours studied. Okay. So that seems fine. Now let's run it. There is one more invalid syntax for the color red. Okay. So that is due to the bracket. So we started the df here and you have taken the red color here, df hours studied. We have to close the marks predicted with a double quote. Let's run it now. So when we run that now, so you get the graph like this. Okay. So now you get the graph between the model as well as the actual values of x. So now you can see that the model tries to predict values close to the actual values. There is no big difference, but what we have to do is we have to identify the accuracy of the model so that we can achieve the best equation. Okay. So we are going to do that stuff. You're going to understand that how we are going to do that. We are going to discuss this thing tomorrow in the session. Now, Hussein is asking, is there need to use NumPy if we have more than one independent variable? Yes, you need to use NumPy if you have more than one independent variable. Moreover, if you're using linear model library, in that case, it asks for a 2D array. Okay, but there is an alternate to it. There is an ordinary least squares regression, OLS, wherein you can directly pass the list values as well for fitting. So you're going to understand such things, that what different functions and classes are available and how and what kind of input values have to be provided. So we have to check the function. So if the function asks us a two-dimensional array, then we have to use NumPy. In case if it can take up a one-dimension array or it can take up a list, then we don't need to use NumPy. NumPy will be used whenever we have to convert one-dimensional array or any piece of data list into a two-dimensional array. For that case, we will be needing NumPy. Okay. So if all the questions are sorted, if there is any question, please let me know so that I can help you out with the queries. Moreover, we'll start our session tomorrow with identification of the accuracy. Yeah, so I have one more question. Yeah, please ask me the question. So in the chat, I can see one more question. You can quickly ask me the question. Yeah, Hussein, you can ask me as well. Okay. So what's the difference between pandas data frame and NumPy two-dimensional array? Okay, so there is a big difference actually. So what NumPy can do, NumPy can give you n-dimensional arrays, which means you can create 2-dimensional, 3-dimensional, 4-dimensional, n-dimensional arrays. What Pandas does is, Pandas gives you access to create a 2-dimensional size mutable structured frame. Okay. So in case NumPy is useful when you have multi-dimensional data. Let's say if it is a 2D, 3D, 4D, you can use NumPy. Moreover, Pandas give you help when you have to read a structured data from a source. So Pandas give you access to read it from HTML, read it from PDFs, read it from different types of data sources. So both have their unique utilities. So we use both of them in combination as per our requirements are concerned. So whenever you have to use multi-dimensional arrays, we use NumPy. When we need to read data, a structured data from a data source, and we want to represent it into a row and column kind of format, in that case, we use Pandas data frames. Is the question solved? Is the question answered? Have you got the answer? Okay, great. So, Sanika, any more questions? Okay, none for now. That's great. So yes, and Sumit sir is asking for reviews on Google, Facebook. Yes, definitely we can go for it. So sir, if it is convenient, you can quickly share the direct links to the participants so that they'll be able to do that. So as far as today's topics are concerned, I hope we have completed today's objectives, wherein we have implemented certain things like we got to know how we can read data. After reading data, we implemented a machine learning framework known as knowledge discovery process. In data mining stage, we have used linear model for implementation of linear regression. We got to know what is a linear regression equation, what is slope and intercept. We got to know how we can compute slope and intercept using actual values of X and Y, the values of dependent and independent. And then we can fit the model. So fitting the model means training the model and computation of slope and intercept with respect to actual values provided. So once we have got the parameters, then we have provided new values of X for prediction. Once we have got the prediction, we have compared the prediction visually and graphically so as to identify that our model is able to predict the scores nearby, but with certain accuracy. So our next objective would be to identify the highest accurate model who can perform prediction of marks. Okay. So thank you so much for the day. Thank you so much for being available. And Sumit sir will be asking you certain links. He will be sharing certain links with you all so that you can share your valuable reviews for the program. Thank you so much for today's session.